and hit the button on here that says apps. Not like you're gonna go out for dinner and just order some apps. These are actual applications. You didn't have conics, right? Okay. So, does anybody else not have the conics app on their cell phone? So, what we need question. So on here, when you get this, multiple things at once here. This will actually show you the different formulas. Okay. Now, when we have this, excuse me, I'm just going to drop these in here, and we'll look at them individually. Notice you have H's and K's. What do you think H's and K's stand for? Right. Horizontal and vertical shifts. The H and K is going to be where all of your centers are going to be located. Okay? All the centers. Oh. What do you think A and B still stands for? A and B doesn't change. This A is always distance from center to, bless you, center from vertex. B is center to co-vertex. C is center to focus. How you find A, B, and C, depending upon whether it's an ellipse or it's a hyperbola, is still exactly the same thing. The only thing that's different is that where you start your graphs and stuff. That's where it just gets a little messy and having to understand how do you walk and plot points and whatnot. Okay. So, actually, let me do some stuff here. No, you don't need to. It's on the calculator, so you don't really need to. Let's see if I can get this to work here real quick. Link. Give me 1 second here. Apps. This should work. Thinking, done. All right. Is yours not having it? Oh, I forgot. Every time I send you guys apps like this, you guys owe me $1. It's like it's cheaper than the App Store, but it's same thing. You think I'm kidding? Receiving, validating. Sorry about this. Anybody else not have the conics on there? Did it show up? We'll get back out. Just hit quit. Hit quit. Second quit. You completely unplug your earphones. You might be able to hear me better. Take out your earphones. You don't need to have earphones in while we're in class. There's a time and a place. This is neither the time nor the place. Anyway, so one of the things I want to show you, the circle. Notice how the circle has another one written all the way out. That's like a foiled out version of it. We don't use that. Okay, we don't use that version, so you don't have to worry about that one. Everything else is just your H's and K's. As we go through these, for every one of the conics, your H and K is always going to be the center, no matter what. Your A value is always going to be, excuse me, your distance from the center to the vertex. Your B value is always going to be the distance from the center to the co-vertex. Your C value will always be the distance from the center to the focus. And then lastly, the what do you call it? The parabola, that 4p. That p value is still the distance from the center to the focus. So when you have your parabola, that p value, that guy is still the distance from the center to the focus. Good morning, sir. How are you? Good, good. Do me a favor. Let me know if you don't have the app that says conics on there, and I'll make sure you get it right away since where all of our formulas are. Okay. And then the opposite of P would be the directors. Everything that we have done is exactly the same. It's just moving away from the origin. This is really what all this boils down to be. Okay? All of the stuff that we've looked at, everything that we've gone through, excuse me, still works the same. Where the a squared is on the hyperbola, I'm sorry, hyperbola, ellipse, the a squared is the larger of the two. Same rules apply. A squared is always the first term for the hyperbola. Same rules apply. The only thing that changes here is that we're just moving things. You still look, all your vertices will always look at a focus. It just moves. Right? It's a matter of understanding how ordered pairs work and how to count. There's a lot of counting involved here. So what I like to do is split these things up into a couple of different days. Usually on the first day, I like to just write equations. And then by tomorrow, we'll graph. And then maybe Monday, we'll write equations, graph, and label, and do everything at once. All right, so each takes a couple days to get through. Not a big deal. But in this case today, I will tell you, excuse me, that you have a hyperbola. Or I will tell you you have an ellipse. So you get accustomed to what it looks like. Eventually, you won't need that. Just like you did yesterday. You didn't need to know if you had an ellipse. You didn't need to know if you had a hyperbola. Because when you rough sketch those plots, you knew which way things were opening. Does that make sense? But today, to help alleviate what do you do to start, we'll write it out. Okay? So I'm saying that we have a hyperbola with foci at 5, 2, and 5, -6, and vertices at 5, 0, and 5, -4. I want to go ahead and rough sketch that so I can decide whether or not which way things are open. Here, unplug your earphones. Come on. You guys, earbuds, everything stuff. Just come on. Unplug everything. We're in class. We don't need to be plugged in. Okay. Excuse me. So start plotting it, and you can start to visualize things better. Foci 5, 2, 5, -6. Just by doing that, you can tell which way it's open. Which way is this open? Up and down, isn't it? The foci are vertical of one another. That means they have to be moving up and down. Okay? So just from that little bit of information, if the foci are up and down of one another, it has to be doing this. Okay? It has to be. So plot the vertices then. Vertices are at 5, 0, and 5, -4. Oop, that was 3. There's 4. Okay. I know vertices look at foci. I know that it has to do this. But now comes the part of figuring out where is it centered? Where is everything at? So as I get into this part here, I'm going to reference my calculator because it's got my formula. I'm going to back up and I'm going to hit the button. It's a hyperbola. And I know it's going up and down because my rough sketch told me so. So I'm going to write down the formula for a vertical, or up and down, if you will, hyperbola. And it's the y minus k quantity squared over a squared minus x minus h quantity squared over b squared equals 1. And now I have to start filling in blanks. Well, here's what happens. We all knew when we were doing our stuff that was non-shifted, our center was always located at the origin. You would just go left or right or up and down to go to the vertices or the co-vertices or whatnot. But the origin was always the dead center of everything. It was the midpoint, wasn't it? Yes, sir. the center is always the midpoint of everything. It's the midpoint of the foci. It's the midpoint of the covertices. It's the midpoint of the vertices. This is why I was saying that a lot of times all you have to do is count. You know that the center has to be located on that y-axis. Sorry, the x value, because it's vertical. Okay, it's got to be on the x value. I was thinking the y-axis going over this way. It's got to be on this imaginary line here. I know that my draw is a little bit better. Sorry. I know that it has to have an x coordinate of 5. I know my h and k has to be 5 comma something. Well, what's halfway between 0 and -4? -2. So where I'm getting at, all you have to do is count. 0, halfway between 0 and 4 is -2. Now that you know your center, you can start to figure out your A values, your B values, your C values. Because the distance from the center to the vertex is the A value, isn't it? How far away are the vertices from the center? 2. Just by counting, my A value is 2. I don't know what my B value is, but I can figure out my C value because the distance from the center to the focus is the C value. So when I count that, I'm going up to here, and down to here. Those two were, what were they, 4 away? All you have to do is count. Since your vertices and your co-vertices will always be on the same line as the center, you don't have to use the distance formula. You're just counting how far away something is. It's really nice to have to do that. So those are 4. So that means a squared is 4 and c squared is 16. Go back to the idea of your a squareds and b squareds for a hyperbola. Is it minus b squared or is it plus b squared? Plus. And what was the trick in remembering that? Do you guys remember? Very good. It's the opposite sign of the formula. Not ever going to make you memorize the formulas, but I will make you have to remember that. So if you remember that it's the opposite sign, 4 plus what is 16? 12. Do I need to figure out what b is? Does it matter? Do I have to graph it? Nope. But by graphing just those couple of parts, it allows me to do the rest of the math. Now I just fill in the blanks. I've got everything. Y minus k. So what's y minus -2? I thought you said 7. I swear, like, I was chopped up and you're just trying to be funny. Nice job. Yeah, I know that. I swear I said what's y minus -2, and I think you said 7.
I heard 5. You heard 5 minus
Y 5. Okay, I get you. All right. So if it was 5, yes, you're right. So how about the letter Y minus a -2? He doesn't want to say it. 7. It goes over the A value. The A value was 4. And there you go. Yes, sir. Remember we had the A value for the distance from the center to the vertex. That was 2. We had the C value as the distance from the center to the focus. That was 4. A squared, C squared. That gave me the 4 and the 16. But then when you used, excuse me, since the hyperbola has the subtraction in between, in order to find the focus, we use a squared plus b squared. So we figured out 4 plus what was 16. Okay, and that's what we're doing. Bless you. I will say one thing when you do hyperbolas. This is, and I'm really glad I always start with a hyperbola. What came first in this case, a y or an x? The y. You guys are so used to doing ordered pairs as x, y, h, k. What you will make your mistake on most regularly with these is you will flip-flop the h and the k because it's not in the order of the ordered pair. Be sure when you are writing out these formulas that you label what h and k is so you can reference your own word. Because a lot of times people make a silly mistake. And this is the silly mistake problem. It really is. Okay? The rest of it's pretty, I mean, as you get into it, besides saying the number 7, the mathing of it is pretty quick, isn't it? Yes, sir.
So how did you get
Distance from the center to the vertex. Okay. And that's why we count and plot. That's the whole reason why when we were doing that stuff, when it was non-shifted, that I would always draw the sketches. Because now it's important. Does that make sense now? There's little methods to the madness of why I've set you guys up. All right. Let's try another one. We'll go from a complex one to the probably the easiest one. That when it comes to the smartboard, there's really not much that I can't do. So, oh, I thought you were trying to be all snooty. You don't know that song? How do you not know that song? Hey, look, it's an ellipse. Not a Mitsubishi Eclipse, it's an ellipse. Shut up. Hey, at least I'm writing stuff down. I was. Anyway, so you have an ellipse. What do you think I'm going to say to do first? Graph it. Okay. Sketch it, graph it, however you want to say it. Okay. Foci, 2 and -4. 5 and -4. Oops. What way is this opening? You're right going left and right, but it's an ellipse. So it's an ellipse here, okay? All right. So we know right away it's got to do this. We know it's going to go like this. Vertices at -1 and 4, -4 and 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we know it's got to do this. Okay. We got to find the center. Well, the center is located at the midpoint of any of those pairs. So what's halfway between 2 and 5? 3.5, right? Confusing. Oh, okay. So my center is at 3.5, here-ish. Okay. So we write it down, H and K. We know it's going to be at 3.5 comma something. Well, what's the something? -4. It's nice, and it's always going to be on that same horizontal line, so you don't have to use distance formula. That's why we only just have to count. Is it okay that we have to count halvesies? Yeah, nothing wrong with that. Okay. How far away is 3.5 from 5? 1.5. Okay. So this is the distance to the focus. So I'm going to start with my C value is 1.5. Can I rewrite that as a fraction? It's going to be a little bit easier to square. What's 1.5 as a fraction? 3 halves. Reason why I want to do that, because when I square it, what am I going to get? 9/4. It's quicker to do fractions than it is decimals. What's 1.5? 1.5. 3 halves. A lot of these, don't freak when you see the decimal stuff. The decimal stuff you get usually halvesies. It's nothing crazy. So it should be relatively simple to work. I wouldn't worry. Yes, ma'am. I'm just doing the midpoint. What's 2 plus 5? Half of it. Yep. Yep. To get to the H and K is always the midpoint of your foci. It's the midpoint of your vertices. It's the midpoint of your co-vertices. That's how you get the H and K. Always. Okay. And then I start counting to get my A, B's, and C's. So my C value was the 3 halves. How far away is, excuse me, 3.5 from 8? Well, let's count. 4.5, 5.5, 6.5, 7.5. So 4.5 away, right? So if my A value is 4.5, what's that as a fraction? 9. That's good. Okay. Now, since this is an ellipse, you're going to subtract. Very good. It's going to be a squared minus b squared is c squared. So we have to square these. What's 9 halves squared? 81/4. Good. So you have 81 over 4 minus something is 9 over 4. Well, here's a dead giveaway. Your denominator is going to be a 4, which makes it 72/4. Huh, 72/4 for b squared. So 72/4. What's half of 72? What's half of that? So what's 72 divided by 4? 18. Yeah, 'cause you gotta simplify it. You can't. 81 fourths, I can't simplify. 72 fourths, I can't. You guys catch on the cutting those two in half? Is that okay there? Because all I did was divide them both by 2. I got, 36 over 2. Divide it again. That's how I get fourths. All right. So now we can finally reference our formula. Now we've done everything else. Our ellipse is going left and right. So it's going to be x minus h quantity squared over a squared. Excuse me. Plus y minus k quantity squared over b squared equals 1. We know our h, we know our k, we know what a squared is, and we know what b squared is. So we just write it out. We get x minus 3.5 quantity squared over 81 fourths. Have you guys ever worked with complex fractions before? Okay. Before I go any further here, let me show you something. A complex fraction is something like this: 3 divided by 2/5. When you divide out by a fraction, when you write things vertically like that. When you did vertical division, do you guys remember what you did horizontally? What was it? Yeah. So this is the same thing as saying 3 over 1 divided by 2/5. You guys okay with that? Which means keep, change, flip. You get 3 over 1 times 5 halves, which makes this 15 over 2. Okay. So this is where when we have this, let me move this up a little bit. Treat this like 1 divided by 81 fourths. That's the same thing as 4 over 81. Yeah. We had a problem like that with the non-shifted before. Remember how it was, I think it was, might have been 4x squared over 81, and then it was minus something, and it was in the limit, whatever it was, where you had to worry about the fractional amount. It's the same thing as making the a squared value a fraction. That's what it looks like. Okay. Anyway, so then we go back to here. Plus y, I forgot what my center was. Y minus 4.
Yeah.
Oh, it's -4. Sorry. So it would be y plus 4. Excuse me. It was negative. Remember our ordered pairs? I forgot to put my h. My h was at 3 halves, or 3.5. Excuse me. But my k value was negative. It was down. I forgot to put the negative on there. We plotted everything correctly, but I just forgot to put the positive. Or excuse me, that it was a negative k value. So then that would have been that over 18. And then obviously this would have been here. And that would have been your formula. So I'm sorry, I forgot to put the minus right there. Now here's the thing. We did everything right, even though I forgot to put the little minus sign for the k value. What would happen if you did all of that right? You had everything here, but you actually wrote y minus 4. I mean, or it's nothing, because there's a lot here. Okay? These take time, and we haven't even gotten to graphing these yet. I mean, you're kind of getting the rough sketch idea. Okay.